Hello, welcome to the video. In this lesson, we're looking at section 5.4. We're going to be solving special systems of linear equations. So up to this point, when we looked at different systems, whether it was graphing, whether it was substitution, or whether it was elimination, we were able to get a solution for x and y. The reason why we were able to get a solution for x and y was because the two linear equations, the two lines in the graph, intersected at a specific point. That specific point just so happened to be the solution that we found. But there are other instances where we may have a potential to get no solution for a system, or we could get infinitely many solutions for a system. And here is the different possibilities. So the first one is to get one solution. The one solution is the one that we've been looking at for the last few sections. That just means that the two lines intersect at a single point, and that's the one solution that you're going to get. The second type of system that you could potentially get is one that has no solution, which means that the lines don't intersect. If the lines don't intersect on the coordinate plane, that means that the lines are parallel. Finally, the third type of system is where both equations just so happen to be the same line, and that means you can get an infinitely many solution system for your result. So these are the three different types. You can get one solution and solve it just like how we've been solving these systems. You can get no solution, or you can get infinitely many solutions. In this section here, it says solve the system of linear equations. So we can solve it however we want. My suggestion is to solve it algebraically, either through substitution or elimination. The one thing that I notice right off the bat is both equations are in slope-intercept form, y equals mx plus b. And I can look here, and what I notice is both equations have the same slope, which means that since they have the same slope, I know that the lines are parallel. But if you didn't see that, let's go about and solve the system. So since both of them are set equal to y, I'm just going to set them equal to each other. So I got 2x plus 1 is equal to 2x minus 5. If I were to subtract 2x to both sides, actually those cancel out. And the reason why it's no solution is because if you look at the constant value results, 1 does not equal a negative 5. Since that statement is false, we get a no solution system. Looking at this example here, again, same idea, but with this one, it's written in standard form, so I can't easily identify if it's one solution, no solution, or infinitely many solutions. Since it's already in standard form, the choice that I like to do is I like to do elimination, whether they give you a single y like they do right here. I just like to use elimination. That's just a preference. Nothing wrong with doing substitution. I'm going to choose to eliminate y, so I'm going to multiply this top equation by -2. And when I do that, I get positive 4x minus 4y is equal to a -6. And then, oh, shoot, my bad. This should be -2, my bad. So what happens is this actually cancels and this actually cancels. So everything cancels on the left-hand side. So I'm left with 0 on the left. And -6 plus 6 is 0. Does 0 equal 0? Yes, this is a true statement. Once every variable is eliminated in one equation by combining the like terms, and I can say that both sides are true, this is a situation where I have the same line where my result is going to be infinitely many solutions. Here are some other examples where let's take a look at number 2. So number 2, I'll do a substitution here because it's already y equals. So I'm going to substitute y into the second equation. So -x plus 3 is going to go into this y here. So this is going to turn into 2x plus 2 times it by -x plus 3 is equal to 4. So when I do that, I get 2x minus 2x plus 6 is equal to 4. These two are like terms, but they're opposite coefficients, so actually they cancel out. So I got 6 is equal to 4. That's a false statement. 6 does not equal to 4. So I have a situation where these two lines are parallel, so this is a no solution. In this particular problem, it says the perimeter of the trapezoidal piece of land is 48 kilometers. The perimeter of the rectangular piece of land is 144 kilometers. They're asking you to write and solve a system of linear equations to find the values of x and y. So perimeter is just the sum of all the values. So what we can say is the perimeter of the trapezoid is going to be 4 plus 2, which is 6x, plus 6 plus 6, which is 12y, is equal to 48. Looking at the rectangular piece of land, 9 plus 9 is 18, so that's 18x plus 36y is equal to 144. So essentially, I have to choose one of the two to multiply by. So actually, what I'm going to do is I'm going to try to get rid of x. And 6 times 3 is 18, but I want it to be negative, so it's going to be -3. So this is going to be -18x minus 36y is equal to 48 times -3, which is -144. So what we got here is 18x plus 36y is equal to 144. This gets canceled, this gets canceled, this is 0, and -144, that gives me 0, so this is a true statement. So this is a situation where we get infinitely many solutions. What that means is you could pick essentially any value for x and y and make it a true statement because these, if you were to put these as like a linear equation, they would actually be the same line. And that is being able to solve special systems of linear equations. Hope this helps. Till next time.